Hey everyone, Mr. Shatter here to wrap up this video set with a look at integration on a graphing calculator, specifically the TI graphing calculator. For this video we're going to use my trusty assistant Kalki for help. Hey Kalki, how are you? Let's get started. So integration on a calculator is just simply a button. That button is NINT, which can be found if you press Math, you press the up arrow, and that's going to give you FNINT, which stands for Function Integrate. And if you have the older software, you're going to see the NINT and then open parenthesis. You have to plug in the function f of x, comma, x as your respect, comma, a, which is the lower bound of integration, comma, b, which is the upper bound of integration. If you have the newer software and you press enter, you're just going to see the normal traditional integral symbol or notation. So let's integrate, I don't know, 0 to pi of sine x dx, and make sure you're in radian mode. The last video said the answer to this should be 2. Hey, thanks Kalki, the answer is 2. So that integral just works like a normal function in your calculator. There are two really big concepts you have to make sure you distinguish between, okay? And the first is just calculating a normal integral. What my calculator just did is found the net area of the curve sine x from 0 to pi. Specifically, it's taking all the area above the x-axis and it's subtracting all the area below. So that's what an integral is. You can think of integration kind of like displacement. Okay, it's kind of like 5 meters forwards, 5 meters backwards, your displacement would be 0. But total area is kind of like your total distance. It's an accumulation of all the area. How much area was actually accumulated in this curve, whether it be above or below. We want to add it up all together. Let's take the integral, for example, that we just did, but instead of 0 to pi, let's do 0 to 2 pi. So I'm just going to go over here. I'm going to do second insert 2. Now we learned in the last video that the answer to this should be 0. And the reason is because there are exactly two units of area above and 2 units of area below. And so what the calculator is designed to do is to say 2 minus 2 is equal to 0. And you may think that if we took the absolute value of this integral, so I just got to type it again, so go math 9, 0 to 2 pi, and we've got sine x dx. You may think that this would give us the answer that we want. The answer that we want is 4, right? It's 2 plus 2, but it doesn't. This gives you 0 as well. And you may be confused as to why this is giving you 0, but it's actually quite simple. All this is designed to do is just take the absolute value of your integral. The integral is 0. The absolute value of 0 is just 0. Instead, what we need to do is we need to take the function sine x, the function itself, and take the absolute value of that. And the reason why, if you take the absolute value of sine x, what that's going to do if we zoom trig it, is take the sine x curve and reflect it all above the x-axis. So if we go back to our integral, and we take the absolute value, and instead of doing it in the beginning, we do it on the function itself. So it's going to look a little something like this. We're going to do math integrate. We're going to go from 0 to 2 pi. And this time, in the parentheses, or the function itself spot, we're going to type the absolute value of sine x. So what this is now doing is it's adding up all the area of this curve that is now bumped all above the x-axis. And that is how we get our desired area of 4. So if you want to calculate the total area of something using the calculator, all you have to do is integrate from a to b of the absolute value of f of x dx. And this will give you all positive area added together. So just make sure you know what it is that you're trying to calculate. Be really tricky, or be really careful with total area, because it can be really tricky. Making sure you know where a function may cross the x-axis, that's really important information, because that'll tell you where to split your integral. You may need a few different integrals and add those all together in order to find an accurate representation of total area.